Yes, we can use these two equations. So we can use T table to calculate these two values. Yes, the above statistic is called studentized range statistic. The quantity under the square root is called the standard error of the difference of or SED. So SED is represented standard error of difference. So I will highlight that part. Standard error of differences. So that's the denominator part. Okay. The quantity under the square root. Sorry, denominator is not denominator. This part. It's called SED. Okay, there are some drawbacks in the test. Let's see what are those. Only one critical value for all comparisons. Probability of declaring a false significant difference increase rapidly with the increase of number of comparisons. So therefore it is recommended that number of comparisons is kept small. Maximum comparison t minus 1. So that means in the other case that says this is good for the comparisons with small number of groups. So you can see some significant applications at the end of this lecture. Okay, now we are going to turn to the Duncan's multiple range test. This test was suggested to overcome the problem with the LSD test if it is used for all possible comparisons. So normally least different tests we apply for the pre-planned comparisons. There's a major applications with that, but if we have to do all possible comparisons, we have to turn to the Duncan's multiple test. Normally we call it as a post-hoc test. So the principle in DMRT is that if the two means compared are far apart, the critical value for the significant difference is large. So these thereby the probability of declaring a false significance is maintained at a fixed level of alpha irrespective of number of comparisons. Okay, these are the steps. So first DMR uh, in DMRT a value called P is representing the range. So first we need to define that one. This range takes account how far apart two means compared is. So this is about how far apart two means compared. Then these are the steps. Arrange all means in ascending order. First, you need to calculate the mean of your individual group. Then we need to arrange those in ascending order. So then we can give values called 1 and 2 and 3, 4. So this is not the order of category. This is the order of the ascending order. Then we can make the mean differences and we can give the range value. So this range definition is somewhat different from the previous cases. Then previous cases in the traditional way, how do we calculate the mean differences? We use we reduce minimum value from the maximum, so that will present as the range. But here it is somewhat different. So when you take the difference in between y and 1 and y2, y bar 1 and y bar 2, there are two groups, so it is has given as 2. So here it is 1 and 3. Then how many ranges are here? There are 3. So that's why 3 is coming in here. In this way, 1 and mean between a bar y1 bar and y4 bar. Then there are 4 groups, so it is given the range as 4. So in this case you need to take that into your mind. Then you can apply this equation for the test. So then the P here represents the Pth range. So you know in this case we have 3 P values, so we have to calculate this one separately for these 4 different values. And the This one, the Q1 is the table value. We are taking the table value with respect to the P and degrees of freedom in error and alpha. So most probably we apply this kind of one for the equal cases of replications. So you can see now, yeah, Duncan test. This is the table. So you can apply values with respect to P, degrees of freedom and the alpha value. Then you can obtain your value from here. Then you can apply that value also into the equation and MSE and divide by this is square root part. And this is the decision rule. Then you can need to calculate the mean difference again. So we have 4 means in number 4 categories in this example. Then we need to take the different value in between real mean value. So here we have considered about the range for the order, but anyway you cannot give values for your considered in groups, and you need to take the real differences of those value, and you can compare those value with this calculated RP. Then if two means are different, sorry, if your calculated mean value of your uh, mean difference values are exceed your RP, that means two means are different. Okay, then Dunnett test. In Dunnett test, this is a special test for compared test of means against a control. So we can use this with the control. So these all applications are based on the objective of our applying experimental design. So you can select the post hoc test based on your application. Yes, the principle in Dunnett test is that critical value is computed based on number of treatments used in the experiment, so including the control also. The critical value D for the Dunnett test with K treatments, okay, is representing treatment amount, is given by in display. So you need to use the Dunnett table to take this value. Then you can apply these equations to find the critical value of the test. So the decision rule is same with the previous one. Mean difference we need to compare mean differences with the D. So mean difference has exceeded the D. That means the two means are different. So there is only one critical value for the all comparisons. So that is a point in this table. So I will show you the Dunnett test. So this is the Dunnett test. You need to have alpha and the number of then the n is representing k here, and number of groups and number of replications here. So you can use it in that way. Finally, we need to consider about the Turkey's studentized range test. STRT is for pairwise all possible comparisons. Here two critical values in computed based on number of treatments using the experiment. So the critical value H is TSRT with K treatment. So you can use the Turkey's table to have this value, and you can fulfill this critical value. Then where M is from TSRT table, if mean different exist age, then mean cases are different. So the decision rule is equal for these three tests. Anyway, you can follow these steps to select a post hoc test. We have discussed 4 techniques. So if pre-planned comparisons can be made, you can use the least square different test. Then of all possible comparisons needed, you can use Duncan test and Turkey's test. If the comparisons is all treatment against a control, you can use Dunnett's test. So with respect to these special cases also, you can consider about the post hoc set. So this is the end of today's lecture. You can apply these all with your previous examples.